Hello, thanks for joining me today. This is Danny, and welcome back to my modded 1.10.2 series. It is finally time to start playing with RF Tools controls. Hooray! It's kind of a programming mod, but it's visual programming where you just click and drag things around. You've got a nice little GUI. We're going to be attempting to set up automation for our deep resonance crystals. And in the process of this, we're going to basically take a look at how RF Tools controls works, and all the different pieces and all the different potential things that we can do with them. Get started with RF Tools controls. There's a few blocks we're going to need and a few items, of course. We're going to need a programmer. In fact, we're going to need a few machines, so we might as well make a bunch of these machine frames, which are basically the same machine frames that you have in RF Tools for anything else. So there's a programmer. That's what we're going to use to program stuff. And then we're also going to need the processor, which requires a couple of these card bases, and we're going to need at least 3 of these card bases. I made 4, so that's okay. Okay, so the processor is the machine that's actually going to run the programs that we create in our programmer. And then we need, in order for the processor to run, it's going to need a CPU core. So that's what we need one of our other card bases for. We may also need a few nodes and a network card. We're not going to do any of the crafting stuff today, so we don't need any of the crafting bits. So just the one type of RAM? I think so. RAM. Yeah, okay, so we'll just get one RAM chip. So that uses up all of our cards that we created, so good thing I made 4. And that's the bare minimum of what we're going to need. Like I said, we may also need a few nodes and a network card. So, but we'll yes, and one more thing we're going to need is a program card. This is where we actually store our program. Great deal of time has passed since my last check-in, and I have spent a lot of time, well, a little bit of time programming and a lot of time debugging, because, you know, that's how programming works. You spend a little time coding and a lot of time debugging. And I have a program that works pretty well, and I'm pretty happy with how it's working out. I'm going to show you how it works first, and then we're going to walk through a couple of simpler programs, because that one is pretty complicated. I'm going to put 4 resonating ore in here first, and then we'll walk through this program to set the catalysts. So I'm just putting 4 resonating ore so that we can watch it go through this entire process fairly quickly. If we have a small amount of liquid crystal in there, it should be pretty fast. So as you can see, the purity is going up because of our filter material. That just happens automatically. We don't even have to do anything about that because I've just always got tons of filter material stocked down here. Oops, and then it gets ejected. The used filter stuff gets ejected in the back, and that's something we set up when we first started playing with deep resonance. So this is empty. So now we can press this button called Set Catalyst. And we want to make sure our purity isn't too low. It's high enough, so we don't have to worry about that. We hit Set Catalyst, and boom! All of a sudden, we've got glowstone in there. It's putting it in one piece at a time, and apparently it's 4 seconds a piece, according to MCJD. So the program waits for 4 seconds, and then it checks the stats again. So right now it's going to bring the stats, or the strength, up to 50%. So it's going to keep doing that until strength hits 50%. And since it's only doing it one at a time, it's a little bit slower than it might otherwise be if it like put a stack in there. But that's just fine with me. So now if we look in here, we should see that we've got blaze powder coming in. Hooray, blaze powder. And this is going to bring it up to 70%. It's going to bring the strength up to 70%. It's also raising the efficiency a little, but that's not what I'm going after right now. Right now it's just looking at strength. And of course, since this is automated, it's okay that it's a little slow. So now we're at 70%. Now you see the beam color has changed, and that is because it is now putting nether quartz in there one at a time. Then it waits 4 seconds, and then it puts another one in until our efficiency gets up to, to 80%. So we'll have strength of 70%, efficiency of 80%. And now it's just going to sit and wait until the purity gets up to 85%, because that's how high our filter material can get it. because the next thing it's going to do is put in diamonds, but we don't want to waste diamonds. We want to let our filter material work because the diamonds will bring the purity up to 100%, but we don't want to start doing that until our purity is as high as it can get with the filters. Oh, and by the way, I have some little debugging messages up here too in an RF tool screen. We'll look at that in a second too. There are a few screen modules that are added by RF tools controls. So our purity is almost at 80%. I mean 85%. And now we have diamonds. Hooray! So it rounded it up. You can see every diamond. I think it takes about 5 diamonds to purify this much. 97. So probably about 1 or 2 more. Oh, there we go. Now we're at 100%. Hooray! So right now our liquid crystal is exactly where I want it to be. These are the exact stats that I want. Now I haven't set up automation to have it automatically drain once it reaches this point, or to move the crystals out there. Perhaps we'll do that at some other time, because this just doing the liquid crystal thing it's been taking quite a bit of time. I mentioned earlier that we might need nodes and a network card. We did indeed. Without them, it would have been much more difficult. So I made 2 nodes. And I made a network card. I've got 1 node here on top of our infusing laser, and then I have another node down here by these basic drawers, which have our 4 catalysts in them. So it turns out that this is, when we get into our program, we'll see that this is slot number 0, this is 1, this is 2, this is 3. And that's the order that we're using these catalysts. And then this is a drop chest. So the way these nodes are set up, you set the nodes in the world, you right-click on it, you give it a channel name and a node name. The channel name determines basically what network it's in, and you can set up the nodes up to 8 blocks away from the programmer block. So you have a 17 by 17 by 17 area in which you can have a network. And this is all wireless, so our processor, I said programmer, I meant processor. Our processor is able to connect to these nodes wirelessly. Once we add a network card and then type, if you hover over the network card, it tells you, we type net, setup, and then the name of the network. So remember, we gave it a network, or the name of the channel. We gave these guys the same channel name. We want them to be a part of the same network. So it's called DR1, which just means deep resonance 1, because I'm so creative that way. And the node is called DR laser. The one downstairs I call DR inv for, DR inventory. So net setup DR1. So we're calling this deep resonance 1. We're calling it DR1. So it says it found 2 nodes. It found 0 crafting stations. We're not doing crafting today, so it found this node and it found the one downstairs. So now we can refer to those nodes in our programs, and just the same way that we can refer to items that are below or above or north, south, east, or west of our processor, we can also do that with our nodes within our programs. So what I want to do, I have a few simple programs that will kind of cover some of the basic concepts that we're going to be using in our more complicated program. Actually, I'll let you take a look at the more complicated program first. So these are my simple programs. This is my more complicated program. So this is all the programming that's required to do what we just saw, to set our deep resonance crystal, liquid crystal, to all the specs that we want. And then this is just a few little test programs that I've set up just so that we can kind of take a look at the basic concepts. So these little blocks are called opcodes, and they are basically like lines of code in our program. And there are multiple different types of opcodes. We have our events. These are the things that cause the program to run. So every program has to start with an event of some kind. In this case, we're using an event redstone on, which basically means that it's going to run when this block gets a redstone signal, or possibly even one of our nodes. Whenever something gets a redstone signal, and in this case, I don't have anything specified, so that means that we didn't give it a node name. So a lot of the stuff that we're going to look at, where we specify our sides and such, will have a node name in them. If we leave that blank, it's just going to be the processor. Otherwise, we would give it the node name, drlaser, or whatever. So we could say, like in this case, if we want this program to run only if we get a redstone signal, only if we press that button, so only if we get a redstone signal on the west side of this block, we can say event redstone on side west. And then we can specify whether this is going to allow simultaneous runs or just a single run. So true means that we're only allowing one simultaneous run. So in other words, if we have a really long program and we press the button and then we press the button again while the program is still running, it's not going to start running the program again. So we're not going to have the program running twice at the same time. And then of course we can run an event on redstone off. We can have it just repeat an event, kind of like Steve's factory manager could, where you would it just constantly runs every however many ticks. So you could, if you wanted to have a program that's just checking some inventory block once every 10 seconds or something like that, you could use that. And then we have signals. We're going to get into signals in a little bit more detail in a second. And then receive message from another processor. These are a little bit, and then the crafting. We're not going to talk about those yet today. So then we have our blue opcodes. These are eval opcodes. They are basically opcodes that give us information. So we can get like the count of items of the inventory inside our processor. Our processor has this inventory over here, where we can store items, like just, items, just like a regular inventory. And we can pull items into there, we can send items out from there, and using this opcode we can query what's in there. And that's basically all these blue ones are, is they give us information. We can get damage, we can get a name of an item rather than the item object itself. We can get RF in a machine, we can read a redstone signal, we can get the max RF in a machine, we can get liquids, we have integers, and then we have our tests. These are basically control pieces that control the flow of our program, and we'll be using those. We'll look at how some of those work. And then the green ones are the actual operations. So these are the things that actually do stuff. So things like moving inventory around, setting redstone signals, and sending messages, writing messages to the console, setting variables, and that sort of thing. And then these orange ones down here are actually also eval codes, just like we have the blue evals up here. The reason these are orange and they're down here is because these are from the Deep Resonance mods. It has an API that allows other mods to add opcodes, and in this case Deep Resonance, which happens to be written by MCJD as well, the same author of RF Tools and RF Tools Controls. That mod added these guys, which allow us to read the purity, strength, quality, and efficiency of our Deep Resonance liquid crystal. So we will of course be using those. So let's look at a simple program here. So this one basically, actually let's just get rid of that and make this really simple. So this one on event redstone is going to, what the frick? That butterfly just opened this door. That is so strange because these, they're supposed to be obsidian pressure plates. I don't know why they're being labeled as wooden pressure plates in Wayla, but I've some weird Wayla stuff lately. I don't know what's up with that. But they're only supposed to be triggered by players, so that is really weird. But anyway, so this program is just going to write a log message to the console within there that says starting program. So if we save this, we give it a name, we give the card a name, and then we stick it in our programmer. And we can have multiple cards in the programmer, and then the cards themselves will be allocated. We can allocate like certain memory slots and certain inventory slots. In this case, we're using neither memory nor inventory, so it doesn't really matter. But now if we give this guy a redstone signal, and we look at our console, we'll see that it says starting program, and that's all it's doing. Of course, it's not very interesting. But now what we're going to do is we're going to take a look at signals. So the signals are events that cause programs to run, And there's a few different ways that a signal can be called. So a signal has a name, and we just give it a name. In this case, I'm calling this signal sinv. So S capital I N V. That's the name of that signal. We can do an operation that sends the signal, and again we specify the name, and in this case we'll have it call sinv. And then when we get a redstone signal, it's going to print this message to the log, to the console log. And then it's going to send the signal sin, which is going to cause this program to then run. This program is just examining some items and printing them to the console. That's all it's doing. So it's using our little blue evaluation opcodes to look at the inventory in node drinv. So remember we named this guy down here drinv, this node. And we have an inventory on top of it. That's this storage drawer, and then we also have an inventory to the east of it, which happens to be a drop chest. In this case, we're looking at the inventory on top of it. So up, drinv up, so that means we're looking at the top. Slot number 0. So remember I said slot number 0 was the first slot in the upper left-hand corner, which happens to have glowstone in it. And then I'm just printing that to the console. I'm printing, when we print to the console, we saw before we did a literal or a constant. We just typed in starting program or here. We can also have it print variables. We can also have it print a function. And there are two functions available to us. There's a ticket, and then there's a last string. We're not going to get into tickets today, but basically last string just means it's going to print out whatever the last opcode returned. So in this case, it's glowstone. And then here we're doing the same inventory, slot number 1, same inventory slot 2, same inventory slot 3. And then I just have a set variable at the end here, just for fun. So we can see how that works. Because we're going to be using these a lot. So the set variable operation allows us to set a variable with a particular value. And in this and it's going to that is so weird. Butterflies shouldn't be able to set off pressure plates. It just seems wrong. So it sets whatever variable number we give it. So in this case, we're giving it variable number 3. It's going to set that to whatever the last opcode returned. So the console is just going to return, it's going to send along whatever it got. So this last item that we evaluated, which happens to be diamond, is going to get set to variable number 3. So there's no particularly good use for that for this program, but it's, just for fun. We're going to press the button, and then we get the list. Starting program: glowstone, dust, blaze powder, quartz, diamond. And then you might also notice that it says diamond here on the screen. So on a somewhat unrelated note, you know what? Let's not talk about that yet. We'll get to that in a second. So I have another program on here called that's being called on signal inv test. So inv capital T-E-S-T. So this one's doing something a little bit more complicated. So it's taking a look at the inventory in our infusing laser. So it's going to evaluate what's in there. DR laser, remember we called this node up here DR laser. This is the inventory underneath it, underneath the DR laser node. So we're going to look at the inventory in DR laser down. So below the DR laser, slot number 1. Now this is important. This is going to be important when we start getting into our deep resonance stuff. This is slot number 1. That is slot number 0. I kind of learned that the hard way. I was trying to pull stuff out of here and I couldn't because I was accessing this slot instead. So make sure we go for slot number 1, and we're going to check to see how much nether quartz do we have in there. And we're going to put that in a variable. So we're going to set variable number 0 to the number of, because we're doing eval count item external, which is going to return a number to the next opcode. And then we're going to do our test. So here's where we're going to be using our little test blocks. So this is the greater than test, and what it's going to do is it's going to evaluate whether the first value is greater than the second value. So value 1 is a constant, it's 32. Value 2 is our variable number 0. So it's going to check, is 32 greater than the value of variable 0, which is the number of nether quartz. So if 32 is greater than how many nether quartz we have, we are going to fetch items from our inventory downstairs on the top side. We're not specifying a slot, but we are specifying that we want nether quartz. So it'll figure out where the nether quartz is. It's going to grab 8 of them, and it's going to put it in slot number 0 in our processor. So that's in here. Now that's the only thing you can do. When you fetch items, you have to bring it to the processor. So if you want to move items from one place, from one inventory to another, you first have to bring it into the processor and then move it from the processor into your other inventory. So in this case, we pulled 8 nether quartz from down there. We put it in here in slot number 0, which would be this slot if our card is in this slot. So this is going to be 0, that's going to be 1, because those are the inventory slots allocated to this slot. If we put it in here, then it's going to be these slots. So this is then going to be slot number 0, 1, 2, 3, 4, 5. And for the variables, this is actually going to be variable number 0. This is going to be 1, and this is going to be 2. In or out now? Jeez. If you want to play outside, or stay in the house. Anyway, and then we're going to do an operation push items, where we're going to, from slot number 0 in our processor, we're going to grab those 8 items that we just put in there, and we're going to put it out into slot number 1 in our DR laser on the downside. So, in other words, if there are not 32, or if there are fewer than 32 nether quartz in here, it's going to grab 8 nether quartz from down there, and it's going to put it in here. So it's going to add 8 nether quartz to this. If this evaluates to false, so this little red thing is telling us this is false, this is the path it's going to take if it's false, then we're going to fetch items out of the laser instead, and we're going to put them in slot 0 in our internal processor, and I'm not specifying an amount. If we don't specify an amount, it's just going to grab the whole stack. It's going to grab whatever is in that slot and pull it all and put it in slot number 0 again. And then, as you might guess, well, maybe you won't guess this because this is different. Then we're going to go down to the DR in node on the east side, and we're going to push those items there. Now that happens to be this chest right here. And this is our drop chest. So whatever we put in here is going to get sent back into our main inventory system. And this is called inv test. Now what we could do the redstone thing that we did with the other one, and we could just change this to send a signal. Instead of sending signal to sinv, it can send a signal to inv test. So we could just change this. And then when we hit the redstone signal, it'll run this program instead of this program. Alternatively, now there are other ways that we can call these signals. And another way that is quite nice is using the screen modules. But let's do this. Let's do this once first. So right now we have no nether quartz in there. So that function. So we have fewer than 32 nether quartz in here because 0 is fewer than 32. So when we press the button, it moves 8 nether quartz in there. Hooray! We do it again, it moves 8 more. And of course what it's doing is it's pulling the nether quartz in here, and then it's putting it out there, and it's still printing out the start program thing. Now, before we move on, let's take a look at the screen modules really quickly because these are really cool. So there's three different types of screen modules. We've got our interaction modules, which allow us to send signals. Instead of having to modify our program to send a signal on redstone, to the different things, we can actually go right here. We've got sinv and then inv test. So we can hit show inv, because that's what I called that button. And then if we look in our console, we'll see that it printed glowstone dust, blaze powder, quartz, diamond. If we hit our inv test, that's the one that's going to add our nether quartz to this. So now we're at 24, hit inv test again. Now we're at 32. Now what's going to happen if we do it again? Take a guess. Yep, you're right. It took it all out. Because remember our program said if 32 is not greater than the number that's in here, it's going to pull it all out and it's going to put it in this chest down here. It's probably gone by now, but Oh, there's still some left in there. Yep, see? And now it's all getting sent back into our system. And or it's going to get sent in here. I've also got some item conduits here pulling this stuff back into our drawers. That was me that time. Can't blame the butterfly that time. And then the other screen modules we have are well, text, that's just regular, because regular RF tools, because I just wanted to say catalyst. And then we have the variable module. So this one basically just prints out the value of a variable. And remember, we were in this program, we were setting variable number 3. That was actually number 3. If we clear that out, we see nothing here. If we run that program again, show env, it says Minecraft Diamond down there. So it's showing us the value of that variable. So this can be a really nice way to like print out messages. You could have a program running and it'll print out messages to the screen and let people know what's going on. I think we're now ready to take a look at the biggie, the big one. Now of course, I've got an event on redstone. So this program, that will run when we hit the redstone button. We probably don't need that anymore because we're using the screen buttons, but whatever. And then I've got 1, 2, 3, 4 different signal events. So we can kind of think of these as subroutines or functions maybe, or go-tos or whatever, if you want to be really old school. So this is our main program right here. It's basically our main loop. And what it's doing is on signal crystal prep, which gets called on redstone, or when we press this button, because it's set to crystal prep, it is going to evaluate our tank below the processor, which should have liquid crystal in it. So if we look, we'll see that it's set to the tank with a node name blank, so the processor. On the downside, so that's the tank underneath the processor, and it's going to grab the purity, and it's going to output that into a variable. And it's going to set variable 0 with the purity of what's in that tank. So if the purity is 85%, it's going to set this variable to 85. One thing I actually didn't mention before is that the little green tabs show the order of the program. So they show what the next step is going to be. So that's how you control the flow of the program. And then of course when we get into our tests, the green one will be the true condition, and that's the direction it's going to go if it's true, and then the red one is the false condition. That's the direction it's going to flow if it's false. So we're going up and then down again because that's how I had to squeeze the program in here to get it to fit. So then we're reading our strength, same idea, the tank underneath the processor. We're setting variable 1 with that, and then we're reading the efficiency, and we're setting variable 2 with that. And then we're doing a test. Is variable 0 less than 10? So is 10 greater than variable 0? And what that's doing is it's saying variable 0, remember, is our purity. So if our purity is less than 10, we're going to send a signal pause laser. So this is our kind of our failsafe, because if you remember from when we started playing with deep resonance, if our purity gets really low, and some of our catalysts will lower our purity, in fact, our glowstone will, all 3 of these actually, will lower our purity as they raise the other values. And if it ever gets to the point where our purity it drops to 0, liquid will start burning up and just being voided. So we're gonna lose liquid crystal, and we don't want that to happen. So I've got this set up as a failsafe. This should never really happen. I don't know that that our purity would ever get that low, but if it does, we want to make sure that we stop this program right away. So it's calling the signal pause laser, which is right here. And what that's doing is it's setting the redstone signal to the laser. Remember our node over there is called DR laser. On the downside, because that's where the laser is, it's underneath the node. And we're setting the redstone to level 0. We're waiting 10 seconds, 200 ticks, and then we're going to call send crystal again. I mean, we're going to call crystal prep again. So we're basically just going to loop. We're going to wait 10 seconds, and we're going to go right back to the beginning. We're going to check all our values again, and then we're going to do this test again. If it's still lower than 10%, it's going to go and wait another 10 seconds. And it's just going to keep doing that until the purity gets above 10%, and then it will move on to the next step, or the next opcode, because this will evaluate to false if our purity is greater than 10. And then we're checking variable number 1, which is our strength. Is that lower than 50? So is 50 greater than variable 1? If it is, we're going to examine the item in slot number 0. Remember, slot number 0 down here is glowstone. So we're going to put that in a variable. We're going to stick glowstone in variable number 4. And then we're going to do an operation, send signal to set catalyst. And that is this line right down here. And one of the reasons I have that in a separate signal is because we're calling that same program for all of our different catalysts. So just so that we don't end up having 5 lines of code that are exactly the same. So if this evaluates to false, eventually our strength is going to be 50 because we're putting glowstone in there. So once it reaches 50, then this is going to evaluate to false, and then the next thing we're going to check is, okay, is our strength greater than 70? And if it is, we're going to do the exact same thing, except this time we're going to go into slot number 1, and we're going to call set catalyst again. So slot number 1 is our blaze powder. So we're going to set this variable to blaze powder, and then call that same signal again. And then once we get up to 70, then we move on to the next one, and we're checking to see if variable number 2, which is our efficiency, is less than 80. So is 80 greater than variable number 2? If it is, then we're going to go to slot number 2, which is nether quartz, and put that in this variable again, and then do the exact same thing. So we're just doing the same thing in all 3 of these cases. Then, once all of these evaluate to false, then we move on to this one, which checks to see if our efficiency is greater than 85%. So if 85 is greater than our efficiency, we're going to go to pause laser again. So the same one that we used as our failsafe up here, it's going to go down here and it's going to pause for 10 seconds. And it's going to let our filter do its work. So it's shutting the laser off, and it's just going to wait for 10 seconds. And it's going to keep doing that until our efficiency gets up to 85%. Until our purity gets up to 85%, at which point it's going to do the next check, which is, well, is our purity greater than 100%? So if 100 is greater than our purity, which is in variable 0, then we're going to examine item in slot number 3 downstairs, which happens to be diamonds, set the variable to that, and then we're going to call set signal again. So now we're just going to do the same exact thing, except we're going to do it with diamonds. Until we get to 100% purity. So once our purity is at 100%, this is going to evaluate to false. And then we go to set redstone 0 on our laser. We grab whatever items happen to be in the laser. So if there's still a diamond left over, there shouldn't be at this point, but just in case, we're going to clean up after ourselves. We're going to grab the diamonds. We're going to put them in we're going to put them back in our drop chest downstairs on the east side, that chest on the east side of the node. We're going to print to the log message, done. And then we're going to set a variable number 3 to that same thing. Because, remember, we've got variable number 3 showing, here on our console. So then we'll see right here, when we just look at our screen, we'll see, oh, it's done. Because it'll say that, it's done. So now let's look at this set catalyst. So each one of these is calling set catalyst with a different item set for our variable number 4, which means that we can use one line of code to do all 4 of those items. So first of all, we're logging the message, setting catalyst, and we're setting that in variable number 3. So when we're looking at the screen, we'll see up here it's going to say setting catalyst, and then actually this variable right here, variable number 4, is the variable that has the catalyst in it. Because remember we're setting variable number 4 up here. So we can look at the screen and we'll see setting catalyst, and then we'll see what the catalyst is that it's currently working on right there on the screen, which is pretty freaking cool. I really like that. First 2 steps, we're fetching the items, whatever happens to be in DR laser, in slot number 1, which is the catalyst slot, the slot right here. We're grabbing that and we're pulling it out and we're putting it in our drop chest. The reason we're doing that is just in case something got left behind. So if I was manually playing around with this and I manually put some cobblestone in there, which I wouldn't, but you know, if I left a catalyst in there, it'll pull it out. So every time it'll check to see if there's anything in there and pull it out if it is. Then it's going to fetch the item from our DR inv downstairs on the upside, so on the top, which is where that little storage drawer thing is. We're not telling it which slot, but we're telling it what item. So it's going to be whatever item is in variable number 4, because remember we set that up here. It's going to pull that into slot number 1 in our internal processor. And then it's going to take what was in slot number 1 in our internal processor and push items to our DR laser on the downside in slot number 1. And that's it. Oh, and then, no, that's not it. Then it's going to call activate laser. Activate laser is this routine right here. It's the only one we haven't looked at. And all it's doing is the opposite of what this one is doing. It's setting the redstone to 15 in our DR laser on the bottom. So it's sending a redstone signal to the laser, which basically activates it. And then it's going to wait 40 ticks, which is 2 seconds, because that's how long it takes to burn through the catalyst. And we put 1 piece of catalyst down here. Did I mention that? Because we have an amount 1. You have to specify the amount, otherwise it'll just grab a whole stack, which theoretically that would work too if you threw a whole stack in there, because it's going to pull it out every time anyway. But I mean, but then it's just doing a bunch of unnecessary moving of inventory around. But it would still work, so whatever. So we're waiting for 2 seconds, then we're sending the signal crystal prep, which is our main loop program again. So we're going to keep doing that, looping through the same program every 2 seconds, basically, until we get to here. And that has no, we're not calling a signal at the end, and it's not connected to any other opcodes, so that's just going to be the end of the program. A couple of things to kind of keep in mind when you're programming and dragging things around in here. Keep an eye on these little buggers, because if we, for instance, if we're moving stuff around, and I end up moving this guy here, oh, it didn't happen that time. Let's say I end up moving this guy here. This guy automatically connected to it. Yeah, that would screw up our program and it wouldn't work. So keep an eye on that when you move stuff around. You double check all of your little connectors. This is so nice. Now I can put a stacker of, actually I could fill up this hopper with resonating fluid, let this tank fill up, and then just press that button and then go about my business. I know this episode was very programming intensive, and probably, I don't know, if you're not like really into programming, it might have been a little boring for some of you guys. I probably will not do this again, get really deep into a program like this. I do definitely plan on playing with RF Tools controls more in the future. But chances are I'll probably just do the program off camera and then just maybe show you briefly what I did. But of course, if you do have any questions, feel free to leave them in the comment section below, or any comments or whatever, suggestions, ideas, or if you just want to say hello, please feel free to do so. And of course, if you did enjoy this, don't forget to click the like button and to join me next time. Thanks for watching.